Welcome to Exploring Computing. Today's video is lists and loops. So one thing that computers are really good at is processing lists of information. And this is both because we don't really like processing large amounts of information. Let's say we need to do a calculation on a single Stanford student, like maybe we're doing a graduation check on a single Stanford student. That doesn't sound too bad. But then if we go, well, we want you to do this graduation check on 12,000 Stanford students, that's sounding like not a lot of fun. So computers, on the other hand, don't care how many items there are, and they're really good at carrying out the exact same calculation on each of the different people in a list, or each of the different bank accounts on a list, or each of the different whatever you have in the list. So lists are super common when processing information on the computer, and computers are great at processing lots of information. All right, so here we're creating several different lists of information. I've got a list of ages, and I've got a list of team members. You can see in each case, the way I'm going to do this is I'm going to have that square bracket followed by a number of items separated by commas, followed by a closing square bracket. And that's going to go ahead and create my list, and I can go ahead and store a list in a variable. So I store my list of ages into the ages variable. I store my list of names in the team members variable. So another thing that you might run into is the empty list. The empty list is a list with no items in it. And so this is an empty list here. I'm going to start with my course list. I haven't signed up for any courses yet. So I've got an open square bracket followed by a closed square bracket. And that indicates that I do have a list. That list is there. It's available for me to put classes in, but I don't have any classes in it yet. We can access individual items in a list using another square bracket notation. If I have the name of a list, followed by a square bracket, followed by the particular index number of the item in the list that I want to access, this will allow me to access an item in the list. So in this case, I'm accessing the number 2 item in my team member list. Now, you might think that that's going to be Hank, but actually it isn't, because it turns out that Python and many other programming languages, but it turns out not all programming languages, thanks guys, start numbering lists with 0. So in this case, Casey will be item 0, Hank will be item 1, and Tammy will be item 2. So this will actually print the string Tammy. We can also use this format, this square bracket format, to change items in the list. So if I say team members bracket 1, again, we've got Casey's item 0, Hank's number 1. And so what I'm actually doing is I'm assigning into team members 1. So I'm assigning into the location that Hank is currently occupying. And this actually does not insert this new team member. This actually replaces this current team member. So Hank is going to be replaced by Joe here. We can add items onto the end of an existing list by using the append. This uses a slightly different syntax than we've seen before. So here I've got the course list with the original empty list that we saw that example a couple minutes ago. And then I use course list dot append. So I take the name of a variable, which is storing the list. I follow it by the period or the dot, followed by append. And so the implication here is that I'm going to append to the list, and the list that I'm going to append to is the list which precedes that period. So in this case, I'm adding to the course list. So it seems like a bit of a difference from what we've seen before. As you'll discover in a minute, they kind of mix up when to use this format and when to use the previous format that we've been using. I think it's a little bit confusing, but that's the way Python defined it. Okay, so course underscore list dot append, meaning I'm appending to the course list. And then I go ahead and append CS105. I can append IHEM6A. I can append Econ1A. And so the end result after running these 4 lines of code will be, I have a list with 3 classes in it: CS105, IHEM6A, and Econ1A. The append only allows you to add to the end of the list. There is a fancier insert that you can use if you want to put items in the middle list, but you won't need it for our class. So I'm just going to go ahead and skip it. Now, sometimes you're going to want to know how long the list is. And so you can determine how long the list is by taking the length. So I'm going to take len, short for length. And I'm going to have a pair of parentheses, and I'm going to pass in the list, pass in a variable that's storing a list, and it will return a number. So in this particular case, since my list had 3 courses in it, this will print, I am taking 3 classes. All right, one of the most common things that we'll want to do with lists is to process the items in the list. And we're going to do that using a for loop control structure. So just as a reminder, a control structure allows us to control when statements get executed and sometimes how many times they get executed. The conditional control structure, which we saw last lecture, executes some statements when a condition is true, and potentially it will also execute another set of statements when that condition is false. So we took a look at the if statement, the if-else statement, and chained if-else statements last lecture. The loop control structure will allow us to execute the same code over and over and over again, and there are several different versions of this. The simplest one executes the code over and over again for all the items in a list. You can also execute the same code over and over again for a set number of times. And you may also execute the same code over and over again until a particular condition is true. We're just going to take a look at that first one. It's the most straightforward. It's pretty easy to use, and it's very useful. All right, so here's our first example of a for loop. I'm going to print out each of the classes that I'm taking. And so the way this works is I create a new variable in the for loop. In this case, the variable is course. And what's going to happen here is that course will be set to different values, one for each of the values in my second variable here, course list, which I previously set, and we saw a little bit earlier. That's the list that I appended a bunch of different items to. And so what will happen is the statements in the for loop, which in this case is the print I am taking course, will get executed one at a time for each of the different values of the course list. All right, so let's take a look at this running in action. So here's my original course list. Previously, I added all the items to it. This time, we're just going to assume that it's already initially predefined. So there's my course list, and here's my little for loop here. And what we're going to do is we're going to perform different what are referred to as iterations of the loop. And so an iteration of the loop means we're going back and executing the statements in the for loop again and again and again. So each of those would be different iterations. So in the first iteration, what's going to happen here is that course variable, which is set in the for loop, is going to get set initially to CS105. And then I'm going to print I am taking CS105. And then the second iteration of the loop, I'm going to go back up and I'm going to reset the value of the course variable to ihum6a. And then I'm going to execute the statement print. And in this case, it's going to do the equivalent of printing I am taking, and then it'll retrieve the value of the variable. So it'll be as if I had that string there, ihum6a there, and it'll print I am taking ihum6a. And then we've got one more iteration. The third iteration, the course is going to be set to econ1a, and this will print I am taking econ1a, and there's my output. So it did exactly what we expected. Now you can kind of think of this loop as being the equivalent of the non-loop version, print I am taking CS105, print I am taking ihum6a, print I am taking econ1a. But because we're doing this in a for loop, we have a lot more flexibility. We can change all the items in the list, and it will automatically change the number of times it's printing. So the loops are super useful and very important when we're working with lists of items. So let's take a quick look at the syntax of our loops. So we've got that word for, and we've got the word in, and then we've got that colon at the end of that first line. And so those are all required, and those are going to just be copied as is. The for and the in, you'll recall, those are what we refer to as reserved words or keywords. The idea being that this is reserved for use by the Python language, and I can't name a variable for, I can't name a variable in. It would get Python very confused, so don't do that. And then I've got the loop variable, and so this is going to be the first time that loop variable is mentioned, and it's going to be used inside of the loop to represent the different values in the next variable, which is a list variable. I should mention that you don't actually have to have a variable in that second position after the in. If you want, you could actually put a list directly there. It's much less common usually as a variable, but it is possible. So here I've replaced the code that we had previously where I refer to the course underscore list variable, and I've just replaced it by just writing the list right there, and that is doable. Okay, then we have our statements, and these are the statements that will get executed over and over and over again for each of the values of our loop variable. I do want to mention that it is possible to have more than one statement. So here I'm printing out two statements. I'm printing out I am taking, and then I print the course name, and I'm also printing the course is a lot of fun. It's also possible to have statements both before and after the for loop. So if you have statements before the for loop, those will get done once before we enter the loop. And if you've got statements after the for loop, those will get done once after we finish the for loop. And so the way that Python's going to determine what is actually repeated over and over and over again is by the indentation. So in this case here, the print my schedule is, that only happens once. The print I am taking course, that happens over and over and over again. And then the print I may add more later, that's only going to happen once. And the way Python can tell the difference between the print statement that happens over and over and over again for each of the courses versus the one that only happens once is that indentation. Because print I am taking course is indented, that's the one that's subordinate to the for loop, and that's the one that will get printed over and over and over again. And again, we could add additional statements that we wanted to carry out over and over and over again, but they would need to be indented at the same level as that one that we've got there. Okay, let's take a look at something a bit more complicated. So this is a example where I'm trying to determine if pizza delivery is available for a particular zip code. And so I'm going to go ahead and come up with a list of zip codes. And then I'm going to ask the user, what is their zip code? So we've got our variable here in the for loop, the zip code variable, and that's the one that's going to have its value changed. So it will be 94301 to start off with, then it'll be 94304, 94305, and so on. And then the statements in the for loop, the ones that are indented over, those will get executed over and over and over again for each of the values in our zip code list. And one thing that you may notice if you look at this carefully is that if we run into a zip code in the list, which is the same as the zip code the user's entered, let's say the user entered 94305, then we'll print delivery is available. But you may notice if we enter in a zip code that's not there, like 90210, that no print statement occurs at all, and basically the user won't see any output at all, and they'll wonder what's going on. So we'll fix that a little bit later. It's actually a little bit complicated, so that'll be the last thing we do this lecture. But I did want to mention that. What we're going to do now is we're going to look at a couple more examples of for loops in action. In this first example, we're going to add all the values on the list. So I've got a list with 100, 200, 150, 400, and I want to know what the total of all of those values is. And so we've got a little for loop. We've got our variable here, number, in the for loop for number in my list. And as you know, number will be set to each of the different values in our list, 100, 200, 150, and 400 in turn. And then we've got that indented statement that's going to get executed once for each of the numbers, once for 100, once for 200, once for 150, and once for 400. Now, that statement there, total equals total plus number, a lot of students find that a bit confusing because, you know, if you kind of think about it, that kind of seems like I'm saying 1 equals 1 plus 1. Like, how can total equal total plus something else unless number is 0? So that's not the right way to be thinking about it. The right way to be thinking about that equal sign is not as the thing on the left is the same as the thing on the right. The way to be thinking about it is I'm going to carry out the actions on the right-hand side of the equal sign, and I'm going to store the result of whatever those actions generate, and I'm going to store that into the variable on the left-hand side of the equal sign. So it's not saying the two are equal when we start running it. What it's saying is I've got a calculation on the right. I'm going to go ahead and carry out that calculation, and whatever the results of that are, you know, whether or not that calculation on the right includes the current value of total or not, I don't really care. Whatever the result of that is, I'm going to store that as the new value of total. So in this particular case, total equals total plus number means retrieve the value of the total variable right now, add a new add the value of the number variable to the current value of the total variable, take the resulting value of the two of them added together and store that as the new result into total. So again, it's not saying that total is initially equal to total plus number. It's saying that after carrying out total plus number, take the result of that calculation and then store it back into total. So, we do use the equal sign, but if you're getting confused by it, you might want to think of it not as an equal sign, but as a operator that says assign into the variable on the left. So assign into total whatever the value of carrying out the calculation total plus number is. All right, so let's actually walk through this. So we're going to go through our iterations. Remember, iterations are the name we give to each of the executions of the statement in our for loop. So in iteration 1, the total is initially 0 because I set total equal to 0 before I started my for loop. And so total starts off at 0, and we start off number as the first number on the list, which is 100. So total equals total plus number. That takes the current value of total, which is 0. It takes the current value of number, which is 100. So total plus number is 100. And so after I execute this whole statement, total's new value will be 100. Iteration 2, total is 100. That's what the result from iteration 1 was. And number is now shifted over to the next number on the list, which is 200. So total equals total plus number. Total is initially 100, number is 200. So 100 plus 200 is 300. And so what this is going to do is it's going to calculate the 300, and then it will go ahead and store that 300 as the new value total. Okay, iteration 3, total is now 300 from iteration 2. Number is now 150 because we've shifted over to the next item on the list. Total equals total plus number. That gives us 450. 300 plus 150. And so total's new value will be 450. And then finally, from iteration 3, total is now 450. So when iteration 4 starts, total is 450. We add that to number, which is 400. So if I add the initial value of total for iteration 4, 450, plus the new value of number, which is 400, I get 850. And so the total new value is 850. That's what gets stored back into total. And so when we ask it to print total, it prints the 850. Okay, we can go ahead and do an averaging. This is another common operation that we might want to do with items in the list. And so you can see that the way I'm going to do this is I'm going to take the total. I'm going to go ahead and create the total just the same as I did in the last example by iterating through the list and adding them all into a total, set the initial value of total to 0, and then go ahead and add each of the individual items in the list into total. And that's going to get me the 850 we saw previously. And that what we're going to do is we're going to take the length of the list. Remember, the len function takes a list as a parameter, and it returns how long that list is. So in this particular case, my list has 4 items in it. So length, my list is going to return a 4. I'm going to take the 850 divided by 4, and that's going to print out 212.5. Okay, let's go back to our delivery example. So you recall that the problem with our delivery example is if the zip code is not found, the basic version doesn't do anything at all. So that's not good. Basically, if somebody is in our zip code range, it'll print out, hey, we can deliver to you, and that'll be fine. But if somebody's not in our zip code range, it's not going to do anything, and they're going to think our program's busted. So that's not good. All right, so what we want to do is we want to determine whether or not that print delivery is available actually occurred. And so either that statement occurred and we printed it, or it didn't occur. So that's a true false value. And so anytime you've got a true false value, you should be thinking about Booleans. Remember, a Boolean variable is something that is either true or false. Okay, so here's my first attempt to fix it. What I'm going to do is I'm going to go ahead and add in a statement. And notice the statement is indented at the same level as the print delivery is available. And I'm going to say zip code found equals true. So what this is going to do is if we happen to run at a zip code that is in the list, we're going to print that delivery is available. And we're also going to set this variable here, zip code found, to true. So that mostly works, but there's a bit of problem. And that is if the print statement doesn't run, if the zip code isn't actually on the list, zip code found is never set. And so what we really want to do is we want it to be set to false if we didn't find it and true if we did find it. And so the way we're going to do this is we're going to go ahead and set zip code found to false initially before we start our for loop. And then as we go through the for loop, if we happen to run into the zip code, that's great. We'll go ahead and print that delivery is available. And at the same time, we will reset the variable zip code found, which is initially false. We'll say, okay, that was set to false before, but now it's true because we found your zip code. Okay, so that's pretty much it. The last thing we have to do is actually do something on that basis. And so after we finish this loop, either zip code found is still at its initial value, which is false, which means we didn't run into the zip code, or we've gone through the list, we have found the zip code, we've reset zip code found from false, and it's now set to true. And then now what we need to do is just check that value, and on that basis, either print, sorry, no delivery is available, or don't do anything because we already printed that delivery was available. So you can see, I'm going to take zip code found, and then you can see I'm inverting the result. So I talked in the previous lecture about how not takes the result and flips it. So in this particular case, we don't really care if the zip code is found. What we really want to know if the zip code was not found. And so putting that not in front of zip code found actually inverts it. So if zip code found is true, not zip code found is false, and I don't do anything. If zip code found is false, as it was initially, not zip code found false is actually true, because again, the not does the inversion. And so it prints, sorry, no delivery is available. So it's a bit more complicated than what we started off with, but this does get us the result we want. All right, that's it for this lecture. We've got a short little video next talking about a few additional Python language features you might find handy.